You know how we all check the weather forecast before we leave the house, right? Rain, sun, snow. We want to know what to expect. But what if you could check a forecast for something else? Something invisible, but lurking inside pretty much every building we enter. Well, let's dive into this fascinating new world of germ forecasting and see how AI is helping to make the very air we breathe a whole lot safer. Just imagine this for a second. You get a notification on your phone, not for a meeting, but a warning that says, hey, the risk of catching the flu in the main conference room is about to spike. Kind of sounds like science fiction, doesn't it? Well, it turns out it's a lot closer to reality than you might think.
So how is that even possible? To get our heads around it, we first need to understand the problem we're dealing with. Let's start with the air we all share and the invisible threat it can carry. Seriously, think about it. We spend almost all of our time indoors, at work, at school, in stores, you name it. And while we get all these reports about outdoor air pollution, we are pretty much flying blind when it comes to the quality of the air inside these shared spaces. We just don't know what's in it.
So how do we even check for nasty germs in the air right now? Well, the way it's usually done is a bit like old-school detective work. Technicians come in, they capture some air samples, take them to a lab, and then try to grow whatever they found on a petri dish. But here's the kicker. The whole process takes a full 24 to 48 hours just to get a result.
And that right there is the huge fundamental flaw. The method is completely reactive. It tells you that people were exposed to something bad yesterday. It's like getting a hurricane warning after the storm has already passed through your town. It's basically a post-mortem, not a way to prevent anything. But what if we could flip that script? What if we could move from just reacting to actually predicting? That's the big question. And it turns out one company is working on a way to do exactly that, predicting the invisible.
This quote just nails it, doesn't it? It's such a simple but really powerful way to think about it. It completely reframes the whole problem. We stop asking what was in the air yesterday, and we start asking what's the risk going to look like in the next hour?
And look, this isn't just some pie-in-the-sky idea. A Korean startup called Q Solutions is actually building a platform to make this happen. They're creating a truly smart system that's designed to stop infections before they even have a chance to spread. Okay, so let's get into the nuts and bolts. How does this technology actually work? Well, it all boils down to a really straightforward two-step process. First, they predict the risk, and second, they protect the space. Predict and protect. Simple. Let's start with the prediction part. Think of it like a four-step cycle that's always running. First up, IoT sensors all over a room are constantly sensing the environment. They're grabbing data on everything from temperature and humidity to CO2 levels and even how many people are in the room. Next, a deep learning AI takes all that data and predicts the amount of airborne bacteria in real time. Then, the system assesses that prediction using a super sophisticated rulebook to figure out the exact infection risk level. And finally, if the risk is high, it sends out an alert to the building managers. And we're not talking about guesswork here. The proof is right in the data. Just look at this chart. The correlation between what the AI predicted and what was actually measured in the air is over 90% accurate. That's an incredibly reliable forecast. So, what does a building manager do with that forecast? Well, this is how that data becomes actionable. They see this dashboard. It's basically a real-time risk heat map. Every room is color-coded, green for low risk, yellow for medium, and red for high. It gives them an instant, at-a-glance understanding of where hotspots might be forming in their building.
But here's the thing. Knowing the risk is great, but that information doesn't mean much unless you can actually do something about it, right? Predicting the problem is really only half the battle. This is where the second part of the system, the protection part, comes in.
Let's just compare the tech for a minute. Most buildings today use standard HEPA filters. And don't get me wrong, they're great at trapping airborne particles. But that's all they do, trap. The germs are caught in the filter, sure, but they're still alive in there. The Q Solution system, on the other hand, uses a plasma filter. It also traps the germs, but then, especially when that AI sends a high-risk alert, it takes the next crucial step. It zaps them with plasma to actively destroy them, literally breaking down their cell walls. It's the difference between catching a bad guy and making sure they're neutralized for good.
And maybe the most brilliant part of this whole design is just how practical it is. This isn't some massive, crazy expensive new system you have to build from the ground up. Nope, it's a smart module that can be retrofitted right into a building's existing air conditioners and purification systems. You're basically upgrading the equipment people already own. It's just smart. All right, so we get the technology.
But what does all this look like out in the real world? Let's talk about the impact it's having on actual people in actual spaces.
This system is being put to the test in the exact places you'd hope it would be: high-traffic, high-risk environments. We're talking about pilot programs in places like pediatric hospitals and nursing homes, the places where we need to protect our most vulnerable people.
So how did those pilot programs go? Get this, the results are pretty incredible. In the spaces where they installed the full Predict and Protect system, they saw a 70 to 90% reduction in the concentration of airborne bacteria. A 70 to 90% drop in infection risk. That is an absolute game changer.
And what's really cool is that the whole solution is designed to scale. It's not some one-size-fits-all thing. It can be tailored for small places like a doctor's office or a daycare. It can be scaled up for medium-sized buildings like a school or a hospital, and it can even be integrated into the massive building management systems you'd find in an airport or a smart city.
Okay, so let's zoom out for a second and think about the big picture here. What does all this mean for the future of healthy buildings? What does it mean for our first line of defense against all sorts of airborne illnesses?
You know, this technology didn't just appear out of thin air. It's a direct response to some really clear and growing trends. The 2020s made every single one of us painfully aware of airborne transmission. Then, looking ahead to the 2030s, we have a globally aging population that's going to make infection control in care facilities more vital than ever. So the logical next step is a future where healthy buildings aren't just a nice-to-have perk, but are seen as critical public infrastructure, just like clean water.
And that really leads us to this final, powerful question. If our buildings can sense a threat as it's emerging and then neutralize it before it has a chance to spread, they stop being just passive structures. They become active participants in our public health. This technology suggests that maybe, just maybe, our first line of defense against the next pandemic might not be a mask or a shot, but the very buildings we live and work in every single day.